Okay. So, now, this your now you assume that let us assume Ig1 actually magnitude Ig1 its angle is alpha 1 and Ig2 actually magnitude Ig2 angle alpha 2, right. So, what we will do in this equation, I am writing 1 or 2 lines for you. In this equation 80, right, in equation 80 you put that one, right. That means, your I k actually I k is equal to your A k 1 I g 1 angle alpha 1, right, and similarly this one A k 2 I g 2 angle alpha 2, right. That means, this one you can write A k 1 I g 1 cosine alpha 1 plus j sin alpha 1, right. Then similarly, this one A k 2 then magnitude I g 2, right, in bracket cosine alpha 2 plus j sin alpha 2, right. So, that means what? That means, I k 1 you can what you call you can write, you take your separate you just real and imaginary part make it together, this side first you collect the real one. So, it is A k 1 I j 1 cosine alpha 1 plus A k 2 I g 2 cosine alpha 2, this is the real part, and then imaginary part j, it is A k 1 I g 1 your sin alpha 1 plus A k 2 I g 2 then your sin alpha 2, right. So, what you do? You take the magnitude of this, right, you take the magnitude of this and then square it. So, if you do so, right, I mean after making this, just hold on, after making this you just take the magnitude of this and then you square it. If you do so, you will get magnitude of I k square is equal to A k 1 magnitude I g 1 cosine alpha 1 plus A k 2 magnitude I g 2 cosine alpha 2 whole square, right, plus A k 1 magnitude I g 1 sin alpha 1 plus A k 2 magnitude I g 2 sin alpha 2 whole square, right. Then what you do? You expand it, right, and then your sin square alpha 1 cosine square alpha 1 this will be 1 if you take count. Similarly, cos square alpha 2 sin square 2 1. So, these two term plus your plus it will be 2 into this one cosine alpha 1 alpha 2, here also 2 into this one sin alpha 1 alpha 2. So, all the 4 terms your all the terms will be common and ultimately it will become cosine alpha 1 minus alpha 2, right. So, you just expand and simplify, this is simple thing. That means, you will get mod I k square is equal to A k 1 square I g 1 square magnitude, again and again I am not telling understandable, then plus A k 2 square I g 2 square plus 2 A k 1 A k 2 I g 1 I g 2, it will become cos alpha 1 minus alpha 2. This is equation 81, right. Now, we know in general P is equal to your power is equal to root 3 V I cos phi. Therefore, for generator 1 magnitude I g 1 is equal to P 1 upon root 3 V 1 cosine phi 1, right. Cos phi and cosine phi 1 or phi 2 are the power factor angle at generating station 1 and 2 respectively. So, that is I g 1 is equal to P 1 upon root 3 V 1 your cosine phi 1, this is equation say 82a I have given, and magnitude I g 2 is equal to P 2 upon root 3 magnitude V 2 cosine phi 2, right. This is given equation 82b, right, where P 1 and P 2 is equal to 3 phase real power injected at plants 1 and 2, right. Cos phi 1 and cos phi 2 is equal to power factors, V 1 and V 2 is bus voltage of the plants, right. So, the next what we will do, this next one is that what is the 3 phase power loss total, right. So, in that case the total real power loss is given by k is equal to 1 to NBR, NBR means total number of branches, right, in the transmission network. So, k is equal to 1 to number of branches, that is why NBR, right, is equal to 3 into magnitude I k square into R k, it is a 3 phase, that is why multiplied by 3, right. So, this is equation 83. Now, this I k square this ik square, in this ik square, this Ig1 and Ig2 you substitute. I am not writing all the step, now you have understood everything, right. So, this Ig1 and Ig2 you substitute here, right, in this expression ik square, and then you put it, this is root 3 is there, if you square it, it will be 3, here also 3. So, the 3 will be cancel actually, right. So, you put it here and use this expression and simplify. If you do so, then you will get R k is the resistance of the branch k, right. If you do so, that is why I written from equation 83, 82a, 82b and 81 you will get, right. You will get P loss is equal to P 1 square divided by V 1 square cos square phi 1, this is magnitude, but not telling again and again. Then in bracket sigma k is equal to 1 to n b r, it is a k 1 square r k, kth term, all the kth function, your kth coefficient, right, or this thing you put in the sigma, but other things you take it out, plus 2 p 1 p 2 cosine alpha 1 minus alpha 2 divided by v 1 v 2 cos phi 1 cos phi 2, take it out, k is equal to 1 to n b r again, number of branches, a k 1 into a k 2 into r k, right, plus p 2 square upon v 2 square cos square phi your phi 2 sigma k is equal to 1 to n b r, then a k 2 square into r k. This is equation 84. That means, this equation, this Ig1 Ig2 substitute here, with that ik square whatever you will get, you put it here, then you make separate the 3 terms, right. Your one is due to your this thing, your what you call P 1 square, P 2 square, another is a product of P 1 P 2, this way you make it. Here is sigma is there, sigma is there, sigma is there, right. So, this is equation 84. Now, this equation, this 84 equation, right, it is the equation 84, it can be written as P loss is equal to your B 1 1 P 1 square, that means this term, right, I will come to that, B 1 1 P 1 square plus 2 P 1 P 2 B 1 2 plus B 2 2 P 2 square, right. So, listen one thing, that this P 1 square P 2 square actually it is taken generator 1, generator 2, no question of slack bus, just is count of your generating power, that P g 1 P g 2. Actually, this P 1 P 2 is nothing but P g 1 P g 2, right. So, only 2 generating units, but when you will do it in general, of course, you have to see that P g 2 P g 3 up to P g m, right. But anyway, this is actually your P 1 your what you call in terms of P 1 and P 2, right. So, this where B 1 1, as we are taking P 1 square, that means this is P 1 square into B 1 1, B 1 will actually is equal to 1 upon V 1 square cos square phi 1 into your k is equal to 1 to n b r a k 1 square r k, k is equal to 1 to n b r a k 1 square r k. Similarly, B 1 2, that is it is P, it is your what you call this term only, right, that is equal to cosine alpha 1 minus alpha 2 divided by your what you call your V 1 V 2 cos phi 1 cos phi 2, because it is product P 1 P 2 is there. So, 2 P 1 P 2 B 1 2 and third term actually B 2 2 P 2 square, that means coefficient of the P 2 square, that is your B 2 2 is equal to 1 upon V 2 square cos square phi by 2 sigma k is equal to 1 to n b r a k 2 square r k. So, this is actually called B coefficient, right. Now, if you look at the dimension of B coefficient B 1 1 B 1 to look, this P loss when you put in real dimension it is megawatt, right. But in this case this P 1 square or P 1 P 2 P 2 square, it is becoming megawatt square, right. That means, what will be the dimension of B 1 1? It will be megawatt inverse, right. That means whatever suppose it is given 0.2, that means 0.2 megawatt inverse, right. So, that is why, because it is square, it is megawatt square, P loss is megawatt. So, B the dimension is megawatt inverse, right. So, once this is done, then this equation actually we can put in general form, for instead of 1 and 2, like the terms B 1 1, B 1 2 and B 2 2 are called, these are loss coefficient or B coefficient, right. Loss coefficient will be better, right, or B coefficient. In general, equation 84 rather can be written as B P Q, right. Instead of your B 1 1, B 1 2, B 2 2, if you assume P and Q, in general it can be written that BPQ is equal to cosine alpha p minus alpha q divided by VP VQ cos phi p cos phi q k is equal to 1 to NBR AKP AKQ RK. This is 85 equation 85 say, right. That means, if you put p is equal to 1 q is equal to 1, you will find this is your cos 01, right. It will be V 1 square and it will become your cos square phi 1, right, and automatically you will get this is actually P 1 Q 1, you will get A Q 1 square into your R K, k is equal to 1 to NBR, right. So, this is from this simple this expression, all these B's, this can be made as a general thing, right. So, it is from here you can make it cos your alpha p minus alpha q Vp Vq cos phi p cos phi q Akp Akq and then Rk. From here you can make it Bpq, and when p is equal to q, you can this one you can make it when q is equal to p, you can get it. So, all these things will get it, and this one is a quadratic relationship, this one, right. So, this one also it can be generalized that P loss is equal to P is equal to 1 to m, Q is equal to 1 to m, it can be made Pp Bpq Pq, this is equation 86. So, this loss expression also if you do this, you will get P is equal to 1 to m, Q is equal, and in this case if you make m is equal to 2, then you will get this expression. Here 2 is there because this term will be repeated, right. This term will be repeated because B12 is equal to say B21, this term will be repeated, that is why 2 is here. So, ultimately if you expand this, there will be 4 terms for m is equal to 2. So, but 2 terms will be common, summation will be 2 P1 P2 B12. So, this term, that is why when we are took your what you call that loss formula, we took no Pi Bij Pj. So, this is the Pg or Pgi Bij Pgj, right, this loss formula. So, this is actually quadratic equation, this is actually this equation is 86. Now, economic load dispatch and loss formula, whatever we have done, right, whatever we have done, this topic all the theory is concerned, some examples are given altogether. I think before 8 examples are shown on this, right. Your objective will be not to practice as far as classroom is concerned very big formulas and other things, right, and simple example, right, and a meaningful example, right, something will be you can solve, right. Take any book and you will find this small thing, only thing is that see that do not make any calculation error, right. I mean when you are using calculator, so do not make any mistake, right. These are the thing. Now, next we will take 1 or 2 example on it, right. So, here this example is taken like this. Here what I will do that A coefficient, one part I will do it for you, other part I will give the answer, but you will do for yourself, right. So, a sample power system is shown in figure 13, this is actually figure 13, right, and your B coefficient, you have to compute B coefficient in per unit and on 100 MVA base, other data are also given. So, this is that network is given, and in this network this is one, this bus actually has taken as say for example reference bus, its voltage is given 1 angle 0, right, and this is bus 1, current from this generator is Ig1, and this is bus 2, current from this generator is Ig2, right, and this and bus 3 and bus 4 they are load bus. So, here the current is going to this load is I3 and this is going to I4 is going to the load 4, right. So, now some data you need some data. So, this is 1 2 3 4 there are 4 branches and current direction is shown I1 is going like this, say I2 going like this is I3, right, and this I4 is going to this load, right. So, in that and this voltage is a reference bus voltage 1 angle 0. Now, I1 is given say 4 minus J1, this I1 is given 4 minus J1 per unit, I4 is I2 is also given 3.2 minus J0.8. So, this I2 direction is shown, it is given 3.2 minus J0.8, right. Then I4 is also given, this is I4 2 minus J0.5 per unit, and I3 this is I3 is given 7.2 minus J1.8 per unit, these are given, right. Now, Z1, Z2, Z3, Z4 this is branch 1, branch 2, branch 3, branch 4. So, Z1 is given 0.02 plus j your 0.8 and Z2 is 0.02 plus j 0.08, Z3 is given 0.01 plus j 0.04 and Z4 is 0.01 plus j 0.04. These all are given, these data are given. Now, we have to find out this B coefficient for this example, right. So, what we will do first? This is the two loads are there, this is load 3 and load 4, it is written, that is at bus 3 and bus 4. So, that means I 3 and I 4 is the total load current, because these two I 3 and I 4 going to the load, right. That means, your total load current, right, is equal to I L is equal to I 3 plus I 4. I 3 is 7.2 minus j 1.8 plus it is 2 minus j 0.50 is equal to 9.2 minus j 2.3 per unit. This is the total load current. Now, the way we have derived this thing formula, same we will do it. Now, imagine plant 2 is off, that means this generator 2 is not there, it is off, right. This is figure 14, I have written here figure 14. As soon as this generator 2 is off, look at that the direction of the current will change, because from this generator only current will flow this here and this way will going to the load. So, this is off, so direction of the current will change, right. That is why that this direction of the current is changed. So, and this is off, that means I 2 actually is equal to I 4, right. So, if it is so, then this at this point you apply Kirchhoff's first law, right. So, that means your I 1 is equal to I 3 plus I 2, and here it is I 2 is equal to I 4, because same current is going here, this is off, right. That means your I 1 is equal to, you apply Kirchhoff's first law here, I 1 is equal to I 3 plus I 2, that is I 3 plus I 2 is equal to actually I 3 plus I 4, because I 2 is equal to I 4, I have written here I 2 is equal to I 4, right. So, is equal to your total load current I L, because this is the I 3 and I 4, the total load current is equal to 9.2 minus j 2.3 per unit, right. And I 2 is equal to I 4. So, I 2 is equal to I 4 is equal to 2 minus j 0.50, because I 4 is equal to 2 minus j 0.50, right. So, all these currents we have got. Now, using equation 78 A 11, right, if you go to equation, let me find out, right, just hold on. Anyway, it has been mixed up. I am telling you that A 11 actually is equal to I k 1 upon the total load current, right. So, this if you use 78 A 1 is equal to A k 1 your I k 1 upon I L, right. So, in that case k is equal to 1, the first branch. So, I 1 upon I L is equal to I L upon I L, because I 1 is equal to I L, because I 1 is equal to just now I have told you that your where it has gone again, right. This is I L total load current, right, and I 1 is equal to actually this I 3 plus I 2 is equal to I 3 plus I L. This is I 1 this I 1 is equal to actually I L, because I 1 is equal to I 3 plus I 2 is equal to I 3 plus I 4, right. So, here it is. So, I 1 is equal to I L, right. That means A 1 will be I 1 upon I L, that is 1. Similarly, A 2 1, that here the direction and the original diagram direction was this way I 2, this way I 2, but as soon as this is off, direction has changed. So, a minus sign will be there, right, because this is off, direction of I 2 is changed from the original one. That is why a minus sign is there, right, and A 2 1 will be minus I 2 upon I L, that is minus 2 minus j 0.5 upon 9.2 minus j 2.3, that will become actually minus 0.2174, right. That is your what you call your A 2 1, right. Then for the branch 3, from the branch 3 it is simple actually, numerator denominator is always I L. So, A 3 1 will be I 3 upon I L. So, I 3 you know 7.2 minus j 1.8 divided by 9.2 minus j 2 point, that is coming 0.7826, right. Similarly, for branch 4 I 4 1 is equal to I 4 upon I L, right. So, it is 2 minus j 0.5 divided by 9.2 minus j 2.3, that is 0.2174, right. Similarly, if plant 1 is off, I mean this one you will do of your own, this plant 1 is off, right. As soon as plant 1 is off, right, that means no current will come from generator. So, I 1 will become 0, right, and plant 2 is this one. So, this current direction all other will remain same, but this one I 1 will become 0, that is why A 1 2 is 0, rest I have computed. So, accordingly you can easily compute this, right, following the same procedure, right. So, I am giving you the final one. A 22 is equal to 0.7826, A 32 is equal to 0.7826 and A 42 is equal to 0.2174, right. So, once that means all the A coefficient are computed. Now, again we will come back to that diagram, just hold on, this diagram, right. So, in this diagram, if this is the reference voltage, right, and all the branch impedance Z 1, Z 2, Z 3, Z 4 all are given, all data are given here, all data are given here. That means, V 1 is equal to, you can write V r plus I 1 Z 1, right. So, V 1 is equal to your V r, this is the reference voltage V r 1 angle 0, right. So, it is actually it is V r, right, this is V r. So, V 1 is equal to V r plus I 1 Z 1. So, V r is 1 angle 0, I 1 is known and Z 1 is also known, everything is known. So, you will get V 1 is equal to 1.198 angle 14.5 degree. That means, delta 1 is equal to 14.5 degree, that is the your what you call at bus 1 the voltage angle is 14.5 degree. Similarly, V 2 is equal to V r plus I 2 Z 2, right. So, V r is 1 angle 0 and I 2 is equal to 3.2 minus j 0.8 and this is Z 2 0.02 plus j 0.08, that means V 2 is 1.153 angle 12 degree, that means delta 2 is equal to 12 degree, right. That means, your generator current I g 1 is given, this generator current your I 1 is actually I g 1 is equal to I 1, right, and I 1 data is given 4 minus j 1, this is given. That means, your I g 1 is equal to 4 minus j 1, that is 4.123 angle minus 14 degree. So, alpha 1 is equal to minus 14 degree, that means, that current angle generator 1 current angle is minus 14 degree and I g 2 is equal to I 2 plus I 4, because this I g 2 at this point you apply Kirchhoff's first law at this bus. So, I g 2 is equal to I 2 plus I 4, right. Therefore, this I g 2 is equal to I 2 plus I 4. So, I 2 is given, I 2 is given, I 4 is also given. So, you put it here I 2 plus I 4 3.2 minus j 0.8 plus 2 minus j 0.5, that actually coming 5.36 angle minus 14 degree. That is alpha 2, that is the angle of the current of generator 2 is minus 14 degree, right. So, once you have got this, then this thing your cosine alpha 1 minus alpha 2 is equal to 1, right, because both alpha 1 and alpha 2 just both alpha 1 and alpha 2 they are same 40 minus 14 degree minus 14 degree. So, alpha 1 minus alpha 2 is 0. So, it is cos 0 is equal to 1, right, and generating station power factor, that is cosine of 14.5 plus 14 degree. So, take for example, V 1 it is 14.5 degree and if you take the current I g 1, right, your I g 1 is minus 14 degree. So, from a reference line, right, it is something like this, your I have told you earlier also. So, if this is a reference line, right. So, this is your voltage angle, this is your V 1, this angle is actually 14.5 degree and the current is this side lagging actually from the reference. If you take this is I g 1, right, and its angle is your 14 degree, it is lagging. So, angle between this voltage V 1 and the current I g 1 this 14.5 plus 14 degree, right. That means, this your where it has gone here, right. That means, it is cos phi 1 is cos 14.5 plus 14 degree is equal to 0.8788. Similarly, for generator 2 same thing, it is cosine 12 degree plus 14 degree, that is 0.8988 degree, sorry 0.8988 sorry, right. So, now loss coefficient equation 85, right. This is the general formula, Bpq is equal to cos alpha p minus alpha q upon Vp Vq, magnitude of course, right, cos phi p cos phi q, sigma k is equal to 1 to NBR AKP AKQ into RK, right. Now, here total number of branch for this network is 4, your total 1, 2, 3, 4, 4 branches are there. That means, your NBR is equal to 4, the total number of branch, right. So, now your NBR is equal to 4 and say P and P is equal to Q is equal to 1, then you find out B11. So, K is equal to 1 to 4, AK1 square into RK divided by V1 square cos square phi 1, right, is equal to, expand this term, R1 A11 square plus R2 A21 square, R3 A31 square plus R4 A41 square, all the branch resistance you know, because impedance is given. So, real part is R, right. So, it is V2 square cos square phi 1. So, V2 cos phi whole square, right. So, put all these values, because now all A coefficient known, R1 is known, cos phi 1 is known, V1 is known, everything is known, just you substitute, you will get B11 is equal to 0.02485 per unit. Similarly, when P is equal to Q is equal to 2, right, when P is equal to Q is equal to 2, you will get B22 is equal to K is equal to 1 to 4 AK2 square RK divided by V2 square cos square phi by 2, so writing as a whole square, right. So, that means you expand this and all the values are known to you, you substitute all these values, you substitute, all have been done. Listen, all these calculations done by me only. So, if I that is every lecture I repeat this once or twice, if you find any calculation or anything, I will appreciate if you can mail me that where is the error, then if any calculation error, then I can rectify myself, I can correct this, right. So, this B22 will be 0.01755, right. For thank you, for B12 will come again.